Potentially. Not in the video, but on the audio maybe. So take your CDs when you get them, all right, and place them. I would recommend against placing them like directly in the middle of your paper. Okay, I suggest kind of like put it up more towards the top, something like this. Okay, and then just trace. We're going to make ourselves a nice circle here. If you have a compass or something, you want to do that instead. That's your prerogative, but I think this is much easier to just trace. Also, I'd recommend that you put like a little dot for the very center of that CD, or roughly where the center is. Okay, it's going to be helpful for later. All right, there you go. And then just pass it down for the next person to use. All right, and then once you have that dot, I'm going to use a straight edge here and try and draw my X and Y axes. Okay, like so. Okay. So, this circle is going to be referred to as the unit circle. Okay? Yes, that's right. Tears of joy, though, right? So, the unit circle is a circle that has a radius of 1. They're thus unit circle, right? Radius of 1. The circle is in the coordinate plane. So this is the y-axis right here. This is the x-axis, okay, and centered at the origin. So I'll go ahead and draw like a little x, a little y there just to see that. Okay, we're going to be using this in our study of trigonometry. Okay, we're going to develop more from this. Today we're going to focus just on angles on the unit circle, both in degrees and in radians. Okay, remember that angles in the coordinate plane, they start on the positive part of the x-axis, and if our angles are positive angles, they open up this direction in a counterclockwise motion, and if they're negative angles, they will go this direction in a clockwise motion, right? So, at this starting position, what angle will we have this labeled as? 0 degrees, right? Okay, 0 degrees. Or in radians, what would that be? So, well, 360 is another degree measure. That's true. Also in the same position because it's one full rotation gets there. But what would the radian measure be for 0 degrees? Okay, so pi over 180 times 0, or if you want to say there, it's going to be 0. Right? 0 degrees and 0 radians, they mean the same thing. Okay? Just like if you have 0 inches, if you convert that to centimeters, guess what? You have 0 centimeters, right? Okay? If you have 0 degrees Fahrenheit, you have, oh, that's different. That's different. That's not the same thing. That's not the same thing. Okay? If you have 0 pounds, you have 0 kilograms, right? But Fahrenheit and Celsius a little bit different there. I'm not sure. Well, I guess I do have an idea about why. But anyway. Well, Celsius, I think, is developed around the idea that at 0 degrees Celsius is when water freezes, and at 100 degrees Celsius, water boils, which maybe makes a little more sense than 32 and I think 212 degrees Fahrenheit. I don't know. That's right. We're Americans and we're stubborn, so that's what it is. Anyway, 360 degrees, what would that be in radians? 2 pi. Remember, we talked about that back when we initially introduced radians, right? How did we develop it? We said, well, 360 degrees goes around the outside of a circle, but so does 2 pi times your radius, right? So 2 pi radiuses, 2 pi radians is equal to 360 degrees there. Okay? So, one full rotation is 2 pi. What would then half of a rotation be from here around to here? What would that be in degrees? 180. Or in radians, pi, right? If one full rotation is 2 pi, half a rotation will be pi. So 180 degrees is pi radians. Oops, I'm off the screen. There we go. Okay, let's go half again. Half of half is a quarter of the circle right here. Okay, what degree measure would be right here? Pi halves in terms of radians or in terms of degrees? 90 degrees. Let's come off the screen again. I'm not doing a very good job here. There we go. All right. So then each quarter is 90 degrees, right? 90, 90 to 180. Then what would this be in degrees? 270. 90 plus 180 is 270 degrees. Or we could say pi over 2, right? So we start at 0, go pi over 2 to pi over 2. Plus another pi over 2 is 2 pi over 2, which is pi. Plus another pi over 2 is 3 pi over 2. Or 3 pi halves, if you like. Okay? So there on the bottom, sorry. I keep doing new information. Okay? Let's go halves one more time here. So half of a quarter is an eighth, right? We're going to go right in the middle here of this part of the circle. And then what angle measure would go right here? 45, right? Half of the 90. What would the radian measure be? Pi fourths. Okay, half of pi over 2, pi over 4, right? And so now you can see, oh, okay, so from 0 to this is adding a pi over 4, plus another pi over 4 is 2 pi over 4, which is really pi over 2. Adding a pi over 4 to 2 pi over 4, we get to here. So it's going to be 3 pi over 4, or yes, 135, adding the 45 degrees there. Okay, plus another 45, we get to 180, or plus a pi over 4, we get to pi. Let's keep going with our degrees here. So from 180, add another 45 for the quarter here, we get 225 degrees. Add another 45, get to 270. Add another 245. Add another 45, we get to 315 degrees. And then the radian measure for 225, well, again, add pi over 4. So pi over 4, pi over 4, pi over 4, 3 pi over 4, 4 pi over 4, so this will be 5 pi over 4 right here. Okay, plus another pi over 4, 6 pi over 4, which is simplifies to 3 pi over 2, and plus another pi over 4, 7 pi over 4. And plus one more pi over 4, 8 pi over 4, which is just 2 pi. Okay, so I'll give you a second here to kind of finish getting that copy down. We have a few more angles to add here. Okay. About twice that many. Well, sorry, we have this many more to add to our circle there. Questions on just this, though, so far? Any questions on just this so far? On where any of these numbers came from? Any questions so far? Are you? Okay. If you say so, I won't make you ask questions. Any other questions? We're all good on this? You're not even sure what to ask, I guess? Is that the problem? Okay. We're all good on this. Okay. All right. Moving on then. So we have a few more angles to add. Okay. So these angles we kind of got just from knowing the fact that, again, starting at 0, if we rotate one full rotation, that's 360 degrees, or one full rotation in terms of radians would be 2 pi. Okay. And then we did fractions. We did half of 360, halfway around the circle then is 180, half of 2 pi, pi, right? And then we did half of that to get the 90 and the pi over 2, because again, half of 180 was 90, half of pi is pi over 2, right? And then half again, half of 90 is 45, half of pi over 2 is pi over 4. There's kind of, for each quadrant, we're going to add 2 more angles in, and they deal with 30 degrees and 60 degrees. Okay, and I'll focus here on the first quadrant for right now. So we could use our little proportion there to figure out what 30 degrees would be in radians, but we can also just use the idea that we already know 180 degrees. Okay, what fraction of 180 is 30? It's a sixth, right? And so 1/6 of pi over 6 will be our equivalent radian measure. Okay? 60 degrees. What fraction of 180 is 60? It's 1/3, so this will be pi over 3 then here. Exactly right. Okay. All right, and then we're going to have some angles here, and then also here, here, and here, and here. Okay. And for these angles, okay, well, they're going to be 60 degrees back from 180. See, we're going in a clockwise direction here, so we're going to go back from 180. So what's 60 degrees back from 180? 120, yeah, 60, 180 minus 60 there, so 120 degrees. And then for this one, we're going to go 30 degrees back from 180. So what's 30 degrees back from 180? 150. Okay. 150. And we'll do the same thing for the radian measures here. We go pi, this was pi over 6, right? Going 30 degrees back is like going pi over 6 back. So take away a pi over 6 from pi. Well, pi is the same as 6 pi over 6. Take away a pi over 6, 5 pi over 6. Okay? We went back 60, which is pi over 3. So take a pi over 3 away from pi. That's going to give us 2 pi over 3. Okay. On into the third quadrant here. Now we're not going to go back from 180. We're going to go forwards, right? We're going counterclockwise again. So we're going to go 30 degrees counterclockwise from 180, which means we'll be at what angle here? 210. Okay? Or from 180 to this angle, we're going to go 60 degrees counterclockwise from it. So that means we'll be at what? Another 60 degrees here, so 240. And of course, we'll add those equivalent radian measures. So we went 30 degrees away, that's pi over 6. So pi plus pi over 6, 7 pi over 6. Okay? Pi over 3 plus pi, 4 pi over 3. Okay? So there's that third quadrant. And then finally, the fourth quadrant here, we're again going to go back from the 360. So 30 degrees back from 360, 330 degrees, 60 degrees back from 360, 300 degrees.
So wait, do we just add and subtract 15 from the middle one?
Kind of, but we don't typically do like so like that would be also including like 75 and 15 degrees, and we don't typically include that in our unit circle. So, I mean, yes, you could if you want to just skip those two, that would work, kind of thing. But yeah. Yeah. So 300 degrees, let's go back again. So 300 degrees, that was back 60, so we're going to go back pi over 3 from 2 pi. 2 pi minus pi over 3 is 5 pi over 3. And then back 30 degrees or back pi over 6. 2 pi minus pi over 6 is 11 pi over 6. Okay. And so these are all the angles that we will be kind of utilizing and for which we will be responsible on the unit circle. Goodness, got to zoom out one more there. Okay. Please make sure that you take the time here to write all of these down accurately, because you're going to need these. You're going to need these. Okay. Maybe I'll zoom in here. So there's your like first and second quadrants. So make sure you got those down.
So wait, do we have to memorize these?
Yes. Okay. Yeah, not a bad idea if you want to maybe even label your quadrants here. Here's this quadrant 1, quadrant 2, okay, and then quadrant 3, and then quadrant 4. Okay, and then there's your bottom half right there of your unit circle. Okay, so I told you tomorrow we have our first timed trig quiz. But I'm going to do something you maybe never have had happen in your entire career as a student. I'm going to show you what the quiz is. Okay, I'm going to show you what tomorrow's quiz is going to be. You ready? Here's tomorrow's quiz. Okay, I'm going to do something even crazier. You've definitely never experienced this before. I'm going to show you the answer key. Ready? There it is. Oh my gosh. What am I thinking?
34 points?
What am I thinking? Yes, 34 points.
I mean, it's pretty easy to get up there.
I would hope so. Okay? You will have 3 minutes to produce this.
3 minutes?
3 minutes. From here to here.
5. This is
If you take 5, well then I don't know what to say. I don't have anything clever to do to that. But you're cutting you off at 3, okay? So yeah, go ahead.
Do you think I have any points for writing your name?
No.
Really?
Oh, thank you.
Wait, do we have to write our name on it? Because that takes like a whole 15
Right.
seconds.
So for those of you that are concerned about that, I will allow you to fold your paper, the upper half of your paper, so you can write your name, and then fold it back, and then we'll have you all flip it once to then start. Okay? If that is a concern of yours.
So would you say it takes you 15 minutes to write your name?
Okay? So,
It takes you 15 minutes to write your name.
15 seconds.
questions on any of this? This is tomorrow's quiz. It will be 34 points, 1 point for each thing. One thing I do want to highlight here, I'm going to zoom in. Please don't forget to put both 0 degrees and 0 radians and 360 degrees and 2 pi radians at this location. Okay, that's the most common place people lose points if they don't just mess up the whole thing kind of thing. All right? Don't do that too. Okay? Question, yes.
Do we have to put the degree symbol?
I would like you to, but I will, I'll probably be okay if you don't.
So is it like the degrees are 1 point in each radian?
Everything on here is 1 point.
Okay.
And the correct location, of course, too. Roughly the correct location. Okay, so let me try and provide some sort of maybe assistance, maybe some guidance here to help you memorize this. Okay, so first quadrant, right? 0, 30, 45, 60, and then 90. The second quadrant, it's all of those angles, but just subtracted from 180. So minus 30, minus 45, minus 60. And then plus 30, plus 45, plus 60. And then minus 60, minus 45, minus 30. Okay? Same thing is true for the radian measures, too. Okay? We have pi over 6, pi over 4, pi over 3. So then subtract pi over 6 from that, subtract pi over 4 from that, subtract pi over, subtract pi over 6 from this, subtract pi over 4 from this, subtract pi over 3 from this, and you get these 3 measures right there. That may be too much arithmetic for you. Some other ways you can memorize this, right? You can see the denominators go 6, 4, 3, 2, 3, 4, 6. 6, 4, 3, 2, 3, 4, 6. Okay? In the first quadrant, it's 1 pi, 1 pi, 1 pi in the numerator. In the second quadrant, the coefficients are 1 less than the denominator. In the third quadrant, the numerator is 1 more than the denominator, right? 7 over 6, 5 over 4, 4 over 3. And then in the fourth quadrant, the numerator is 1 less than twice the denominator. So, right, double that is 6, so 5. Double that is 8, so 7. Double that is 12, so 11. Okay? You can do this, but you might have to invest a little bit of time. Okay? Figure it out.
Would a calculator help us on this?
There will be no calculator available. No calculator. Just your brains. Okay? So, questions on any of that? Nope? Okay. Can't believe I just showed you what the quiz was, but, I'm just feeling pretty generous, I guess. If you couldn't tell, right, trigonometry is the place where things start to get a little bit more difficult, right? For some of you guys, you have not seen this material yet. Up to this point, right, it's all been Algebra 2 review. And so this is new stuff, so, Heads up, right? And this is going to be the case for the next unit or two at least. Okay, so keep that in mind. All right. We're not done for today, though. I have some other material I need to still show you. So if you would, please get a piece of paper out. We're going to do some quick review of other trigonometric topics. Where are we going? It's because the weather's nice. They don't want you guys going outside and thinking that questioning your time in here.
I don't remember how to escape this fire.
Yeah, I don't know.
No, they're just wondering when they're going to have the next one.
Wait, how do you walk out of here?
You walk, do not run to the nearest exits. Well, if everyone runs, then people get hurt.
Yeah, then we sue.
That's right. Except you can't sue the school. We have no money, so.
Have you already schooled
You can't get blood from a turnip, you know? That's what they say. Okay, so we're going to go back to geometry here, okay? Because I know some of us, we're all kind of at different places in a certain extent about, how much we know about trigonometry, how much we remember. So, okay. Sine, cosine, and tangent, right? Abbreviated SIN, COSTAN, respectively. Okay. You have no respect? Okay. Three other trig functions that you may not be so familiar with, but we're going to also talk about: cosecant, secant, cotangent. Okay, CSE, cosecant. SEC, secant. COT, cotangent. Okay. These six we will now be responsible for. All right.
Not on tomorrow's quiz, right?
Not on tomorrow's timed quiz, no. In the future, yes. Okay. What are these ratios? What are these functions, really? Because these are actually trigonometric functions I should talk about here. I guess I'm calling them ratios, but they're really functions. Okay. Remember that it's not sine times x. It's sine of x, cosine of x, tangent of x, okay? So I never want to see you divide by just the word sine. I never want to see you just divide by the word cosine. So it's not cosine times, it's not sine times. It's sine of, cosine of. Okay? So, is anyone here completely unfamiliar with secant, cosecant, cotangent? You guys have seen these before, or you're just too scared to put your hand up. Joshua, you've never seen these before. Okay, good to know. So, cosecant, secant, and cotangent are merely the reciprocals of sine, cosine, and tangent. So, in other words, cosecant of x is really just 1 over the sine of x. Okay, secant of x is really just 1 over the cosine of x. And this maybe is one of the dumbest things in mathematics. I looked this up and I couldn't ever really get a good answer about why this is. But why you would go from sine to cosecant and then cosine to secant never made any sense to me. Not really sure why that happens. Okay, but so it goes. All right. So reciprocal of sine is cosecant, reciprocal of cosine is secant, and then the reciprocal of tangent is cotangent. So 1 over the tangent of x there. Okay. What is the importance of these functions? What are they at their core, at their basic understanding? These relate parts of what kind of shape? A triangle, specifically what kind of triangle? Not necessarily equilateral. Could be equal. Sometimes isosceles, but more specifically right triangles, okay? trigonometry, these trig ratios we use in right triangles. Okay? So, how do these things relate? Well, let me just kind of, let's see, talk about this here. Remember that sine of something is equal to the opposite leg, all right, guys, over the hypotenuse. And then cosine of x is equal to the adjacent leg over the hypotenuse. Okay, and then tangent of x is equal to the opposite leg over the adjacent leg. Okay, I know this is like super basic review from geometry, but I just want to make sure that we're all kind of on the same page. Okay, adjacent leg for cosine. Don't just say the word adjacent there, because you might then, use the hypotenuse mistakenly. Okay, because the hypotenuse would be adjacent, a side, but not necessarily the leg. Okay, what makes a leg in a right triangle? So, go Rebecca, go ahead.
Not the hypotenuse?
Yeah, that's what I was gonna say.
Okay, not the
Shorter.
hypotenuse. Okay, it's shorter than the hypotenuse. Yeah, what do you want to say one? Vertical. Sometimes it's vertical, but it doesn't have to be.
It like makes up the right angle.
Aha, okay, so that's another way to think about it too. So either you could say it's not the hypotenuse, so then what's the hypotenuse then in that case, Andrew?
The hypotenuse.
Not the
It's
legs.
Not the legs.
Oh, no, but it's opposite the what?
Right angle.
Opposite the right angle, okay? Hypotenuse opposite the right angle. The legs are adjacent, we would say, to the right angle, okay? So that's right. Okay, so we have these three bits right here. So, and of course, then we have a mnemonic device. And what is that? What's the word we use to help us remember this? SOHCAHTOA. Okay. SOHCAHTOA. Sine is opposite leg over hypotenuse. Cosine is adjacent leg over hypotenuse. Tangent is opposite leg over adjacent leg. Okay? So what these trig ratios, what these trigonometric functions do is they relate an angle in a right triangle to a ratio of some of the sides in that triangle. Right? That's how you guys use those, and that's how we're going to look at them just for a few problems here real quick. Okay? So I'm going to label some angles, capital A, capital B there. 3, 4, and 5 in there. Okay, like that. Okay, classic 3, 4, 5 Pythagorean triple. Right. And let's say I wanted to find the sine of angle A, right? By the way, sine, cosine, and tangent, their inputs, their domains are angles, right? Their outputs, their ranges will be ratios. So we always input an angle into sine, and we get out a ratio. So here's angle A. What ratio of the triangle's sides here will that be equal to? Opposite leg, right? Opposite leg, 4 over the hypotenuse of 5. 4/5. Very good. What about the cosine of angle A? Yep, adjacent leg 3 over 5. And then finally, what about the tangent of angle A? 4/3. 4 over 3, right? Opposite leg over adjacent leg. 4/3. Okay? Easy peasy, right? Here's one for you guys to try. So you guys try this one. Every time I do that. That is the Greek letter theta. It's a capital theta. Okay, capital theta there. Put that angle in there. I'm going to label some sides here. Okay, and I want you to find sine of angle theta, cosine of angle theta, and tangent of angle theta. Okay, just give me their ratios that they are equal to. All right? Go ahead. What's that? Yes, we do. My CDs.
Think about it.
What's
Where is
the
it
equal?
equal?
The square root 2.
It's like two squared.
If It's
No, the 60 would still be.
No, but the other part.
60 would still be the same triangle. 60 is just the other half.
Square root of 3 over 2.
Like you said.
She thought it was the cosine of that letter squared.
oh, jeez, yeah, my handwriting.
I guess I didn't know that.
Yes. Go ahead. All right, how about Lauren C? You have an answer here for us for sine of theta?
1/2.
1/2. Very good. Wait a minute. Where'd that 2 come from? I didn't give you a 2.
It's from using Pythagorean theorem.
Right. Okay. So Pythagorean theorem still applies here, right? It's a right triangle. So use Pythagorean theorem, right? Root 3 squared is 3, plus 1 squared is 1. 1 plus 3 is 4. The square root of that will then be 2. So that's a side length of 2 there by the Pythagorean theorem. Okay? So very good, Lauren. All right, how about then Jackson? What's cosine of theta going to be?
Root 3 over 2.
Root 3 over 2. Very good, sir. And then tangent of theta, let's go to Cameron C. Oh, he went. Cameron S. How about you go ahead, fill in then for him? 1 over root 3. Or if you rationalize that, root 3 over 3. Okay. I don't know how many of you guys actually rationalized it. Okay. You did? Nice. Nice. Okay. It'll be helpful, maybe. Okay. Be able to do that. Okay. Not quite done yet. I have a few more things I just want to show you here. There it is. All right. We need to be able to use our calculators here, so you may want to get your calculators out. Okay, so go ahead, let's figure out what sine of 135 degrees is using our calculators. Okay, so go ahead and type that sine of 135 in your calculator, hit enter, see what you get. Okay. Did anyone get 0.7071? No one got 0.7071? Oh, Anna did? Just Anna? Anyone get 0.0883? Okay. Well, you can see I got 2 different answers there, typing the same thing in. Which one's right? They both are, in a sense, but
One's in radians,
one's in radian, one's in degrees. Hello? Hi, Lindsay. How are you? Not a problem. I do. Sure, no problem. Bye. Miss Baker wants to see you. Do you know where her office is? Okay. Okay, she is pretty awesome. All right, so anyway, the trick here is that, right, we are talking about degrees versus radians. The angle here is degrees. So, mode, I'm in radians right now. I need to switch to degrees, hit enter, and now when I do sine of 135.707 is the correct answer there, okay? So watch out for that. Especially in this unit, we are going to be moving between radians and degrees. So make sure you're constantly checking to see that your calculator is set to the right mode, okay? Or else you're going to get error. You're going to get the wrong answer. Okay. What about something like this? Cotangent of 195. What button do we press for cotangent? So second tangent is a good thought, especially with the idea that we know that cotangent is 1 over tangent. Second tangent gets us this, which is like, oh, Mr. Wood, that's tangent to -1. We know when we raise something to the -1 power, that's the same thing as 1 over that thing. And that does make sense. But actually what this command means is tangent inverse, or arctangent. We'll be using that in a later unit, not right now, okay? So that's not going to help us. So the question is, again, what do we press to do cotangent? Well, what is cotangent? It is 1 over tangent. So 1 over the tangent of 195 is what you're going to type in. That's how you evaluate cotangent. You make it 1 over the tangent of 195. Okay, like so. And you get about 3.732. Okay? All right, so let me give you guys one to try here. Secant pi over 2. Go ahead and do secant pi over 2. What mode should we be in, by the way? Radian mode. Make sure you're in radian mode. What are we getting? Error? What are you talking about? That's right. This one is actually undefined. That's an answer. Okay, believe it or not, it is possible for that to happen. And we'll talk about why that is in the first case. Well, let me back up a step here. What's cosine of pi over 2? Just type that in your calculator. What's cosine of pi over 2? 0. So why might we be getting an error when we do secant of pi over 2? Can't divide by 0. Okay, it's undefined. Okay, in fact, the graph of secant has an asymptote at pi over 2, vertical asymptote. Okay, one other thing to talk about here, real quick, and I'll be able to give you guys some time to work on your. Whoop, we already saw that. We don't need to see that again. And that too. Okay. Pens. Where do I hide them? I don't know sometimes. All right. Oh, wait, there it is. All right. We also are going to use these trigonometric functions to solve for pieces. We're going to focus on just solving for sides, missing sides right now, and then we'll talk about solving for angles later, okay? Because that's a little bit different. I want to be more careful with that when we talk about that one, but we'll talk about just solving for sides for right now, and then later we'll talk about solving for angles. Okay, so I'll just do one example here, and then we'll get you guys started on your assignment. Okay, Right triangle, right? Very important that's a right triangle. We can't use sine, cosine, and tangent on their own if it's not in a right triangle. All right. I'll give this side a measure of x. I'll give this side a measure of 4. And I'll give us this angle here as being 30 degrees. So, we have an angle. We have this side right here, and we have this side right here. What trig ratio might be a good idea to use here? Could we use any of them? Why can't we use just any of them? So we're missing the leg adjacent to the 30 degrees. So that means we can't use cosine. Cosine requires that we use the adjacent leg. We can't use tangent because tangent also requires we use the adjacent leg. So we can use what though? Sine, because we have the unknown opposite leg and the hypotenuse here. So the setup would be what? Sine of 30 degrees. Put your angle in for the sine of the angle equals the opposite leg, x, over the hypotenuse of 4. To solve for x in this equation, what should we do to both sides? Multiply by 4. X is precisely 4 times the sine of 30 degrees. Precisely that, but of course, we would prefer to get something that means a little bit more to us, so we'll type that in our calculators, making sure our mode is set to degrees. We get 2. That's nice. Exactly 2. Okay. We can. How can we find the other side if we wanted to now? We could use Pythagorean theorem. Is that the only option we have? What else could we use? Pythagorean theorem would work there.
Isn't there a special ratio for right triangles that are equals like 30, 60, 90? And
Yes, so it is a special right triangle, so we could use that and like do like a similarity kind of thing. You'd have to remember the ratio though too. So okay, that's fine if you don't. That's okay though. Yeah. Perfect. Well, we used it. Go ahead, Juan. Cosine of 30 degrees, exactly right. Cosine would allow us to say then, we could maybe use y here. So we could say, okay, well this side, we'll call it y. We could say cosine of 30 degrees equals adjacent leg y over hypotenuse 4, and then multiply both sides by 4. And, yeah. And it's going to be, it's going to be 2 times the square root of 3. Precisely, but as a decimal, whatever that's going to be. Okay? So that's how we're going to use trigonometry here to solve for missing sides and things too. Questions on any of this? Okay. So, again, you have some homework on Google Classroom, so I suggest you get started on that. Or you can work on your TenMarks assignment due Monday, or you could start reviewing and studying for that timed trig quiz tomorrow. First one. Okay.
So we can get this so I can draw it again for practice.
Give you what? Oh, yeah, that's fine.
And I want to practice doing it 30
He wants a beautiful circle, though, not some. Yes.